In this lesson, we want to be able to say that I can evaluate numerical and algebraic expressions by using the order of operations. Well, let's just quickly refresh about some words. We have evaluate. To evaluate something means to find the value. To find the value that the expression has. Okay, so we are going to be evaluating expressions. So we are going to be able to find the value of these expressions. Order of operations, you guys have all heard of order of operations. It's the order in which we evaluate an expression. The famous phrase is PEMDAS. We have P, we have E, M, D, A, S. PEMDAS. P stands for parentheses. The E stands for the exponents, so something raised to a power. The M and D stands for multiplication division. And with PEMDAS, it's whichever one comes first from left to right. So this is multiplication division, whichever one comes first from left going to right. And addition and subtraction is the A and the S. And this is also whatever comes first from left to right. Also remember, we do have certain properties for the for making sure that we have commutativity, making sure that we can move things around. So those properties can help out as well. So we have PEMDAS, that's order of operations, the order in which we do something. Here's an example. Evaluate the following expressions. These are really simple expressions. This is more to get you guys used of exponents. This exercise right here is just to try to get us used to exponents. So 3 to the power of 5. This is like saying 3 times 3 times 3 times 3 times 3. We have 5 of those 3's. So we're going to end up multiplying them. 3 to the 5th, 3 times 3 is 9. Let's go ahead and multiply this 3 and 3, so that's 9. 9 times 9 is 81. And let's go 81 times this last 3, and that is going to be 243. So that is the evaluation of that expression. Part B. This should be part B, not part C. Part B. Negative of 8 to the power of 2. The power of 2 says that we're multiplying the 8 2 times. Notice this negative is not inside parentheses. If they wanted it inside parentheses, they would put it inside parentheses. So what this is saying is negative of 8 times 8. 8 times 8 is 64, so this is negative 64. Part C. Negative 5 to the 4th. Notice that negative is inside of the parentheses. So this is saying negative 5 times negative 5 times negative 5 times negative 5. Okay, well 5 times 5, negative 5 times negative 5 is 25. This will be another 25. And it's going to end up being positive because we have an even number of negatives. Even number of negatives equals a positive. 25 times 25. Okay, 25, 25. 5 times 5 is 25. Carry the 2. 5 times 2 is 10. Plus 2 is 12. 0 for place value. This would be 10. 2 times 2 is 4. Plus 1 is 5. Add those together. This would be 625. So the evaluation of that expression is 625. And we are going to move on to the next example. In this example, we're going to actually use more of PEMDAS. The parentheses, the exponents, multiplication, division, the addition, subtraction from left to right. So we're going to start here on the left-hand side, and we're going to start by looking at that fraction. That fraction has 2 parts. We have the top, the numerator. We have the bottom, which is the denominator. It splits it up into 2 sections. So we need to simplify both the top and the bottom. Technically, the bottom is like saying we have a parenthesis. So let's try to simplify the bottom of the expression. So we have 21 divided by, well, we had to do the exponent first. So 3 squared is 9 minus by 6. We're going to rewrite this exactly like it is. Finish up with simplifying the denominator. So 21 divided by 9 minus by 6 is 3. And then this plus 6 times 2. We said with PEMDAS, we do whichever one comes first. If division comes first from left to right, we do that first. If multiplication comes first, we do that first. So we have a division, 21 divided by 3, which gives us 7. So we have 7 plus 6 times 2. Remember, we had to do all the multiplications and divisions before we do any additions and subtractions. So we need to do that 6 times 2. So this is 7 plus 12, which gives us 19. So evaluating this nasty expression, we get this nice number of 19. Looking at the next one, we see we have parentheses of 5 plus 3, quantity squared. We subtract 4 times 6, and then we divide 2 on that. Order of operations. Let's start with the parentheses. Inside the parentheses, we have 5 plus 3, which gives us 8. So this is going to be 8 squared minus by 4 times 6 divided by 2. Next, we're going to do the squared because we have no more parentheses, nothing else to do in there. 8 squared is 64 minus by 4 times 6 divided by 2. No more parentheses, no more exponents. Let's go to multiplications and divisions, whichever one comes first from left to right. So this means we do the 4 times 6 first. 64 minus by 24. Now we have to divide by 2, so 64 minus by 24, divided by 12, because we now have to do that division. And last thing we do is the subtraction. So 64 minus by 12 is going to end up to be 52. So evaluating that expression, we end up with 52. Here's another example, or another type of problem that they can give you. We want to evaluate, meaning we want to find the value of 5 times p minus by 2 times q whenever, or when, p is equal to 3 and q is equal to 8. This is going to be more order of operations, but now we have an extra little step. Notice they say that p is 3 and q is 8. What this means is we just have to substitute. We have to replace those values. So we're going to have 5 times p is 3, minus by 2 times q is 8. So this is going to give us, we do our order of operations, start with our parentheses. There's nothing to do inside those parentheses. We have no exponents. Then we have to go to our multiplications, divisions. 5 times 3 is 15. 8 times 2 is going to be 16. Subtract those, this will be a negative 1. That is that expression evaluated with those values. Part B. This one looks ugly. We have a to the power of x minus by b divided by c times d. If we know that a is 3, b is 28, c is 7, d is 2, and that x is 0, then what would be the expression evaluated? So what we're going to do, we're going to take each of those values and put it in place of the variables. So we say that a is 3, so let's plug that in. We have 3 to the power of x. X was 0. We then go minus, the value of b is 28, divide by c times d. Well, c is 7, so we plug in 7 for c, and we plug in 2 for d. No more letters, just numbers in those spots. Okay, now let's do our order of operations. Parentheses. Inside those parentheses, we have nothing going on. It's just those independent numbers. So let's move on to exponents. We have an exponent of the 0 power. Anything raised to the 0 power is 1. So this is 1 minus 28 divided by 7 times 2. No more parentheses, no more exponents. Multiplication, division, whichever one comes first from left to right. So we had to do this division first. So 1 minus by 4 times 2. That's the division first. Now we had to do the multiplication because that's next in line. So 1 minus by 8. And last thing that we have is just additions and subtraction. So 1 minus by 8 is negative 7. And that is the evaluation of that expression. Remember, we are just substituting those values in, taking the place of those values, then simplifying. Here's another one. Let's look at this example here. This one looks ugly. We have a bunch of a's and b's in here. We have a squared minus by b squared. That quantity divided by, or is being divided by, a minus b. And then we're going to cube that. And then we're going to add 2 times a times b. What we're going to be doing with this is we know that a is 7 and b is 3. Anywhere you see an a, put a 7. Anywhere you see a b, put a 3. So in other words, this is going to be parentheses, big parentheses. We have 7 squared, let's put parentheses around each of our numbers, minus by, oh, that's a b, so let's put a 3. This b squared, divided by, oh, another a, which is 7, minus by another b, which is 3. Let's make sure we put parentheses around everything we're substituting, plus 2. There's another a times 7, and lastly the b, which is times 3. No more letters, just numbers. So what we had to do from here, PEMDAS. Start with our parentheses. Inside our parentheses, we do have other little parentheses, but nothing's going on in there. So now let's deal with the exponents. 7 squared is 49. 3 squared is 9. Divide by 7 minus 3. Then we're going to go plus 2 times 7 times 3. We're just slowly simplifying. No more exponents. Besides the 3 on the outside, which I forgot to write on each of those. So make sure we have everything written down exactly like it says. From here, no more exponents inside. Let's simplify. So we end up with 49 minus by 9, which is 40. 7 minus by 3, which is 4. This is cubed plus 2 times 7 times 3. From here, we're just going to simplify this down a little bit more. 40 divided by 4 is going to be 10 cubed plus 2 times 7 times 3. 10 cubed is just a 1 with 3 zeros behind it. Right, 10 times 10 is 100 times 10 more is going to be 1,000. So that's why we have 3 of those. Let's go ahead and do the multiplications of those. 7 times 2, which is 14. Then we do the 14 times, let's actually just write that down, 14 times 3. So 14 times 3, 4 times 3 is 12, 3 times 1 is 3, plus 1 is 4. So this is equal to 1,000 plus 42. Adding those together, that's 1,042. That is that expression evaluated, 1,042. Main thing, find the variables, substitute those values in place of, then use PEMDAS, order of operations, to simplify it down. Okay, here's another example. A phone plan uses an average of 15 gigabytes of data per month for video streaming and 6 gigabytes per month for music streaming. We want to write an algebraic expression for the total number of gigabytes used in M months. Okay, so we want to know how many gigabytes we can have in M number of months. So we have 15 gigabytes per every month. So first month we have 15, second month we have 30, third month we have 45, fourth month we have 60 gigabytes that we're using. So it's 15 times however many months we have. The other thing is we have 6 gigabytes for every month of music streaming. So this is, for the first month we have 6 gigabytes, for the second month we have 12, for the third month we have 18, and so on. Well, if we wanted the total gigabytes, we need to add them together. That's our expression. Last thing, how many gigabytes of data will be used at the end of 4 months? Well, M stands for months, So that means that m is equal to 4. So let's substitute that into our expression right there. So we have 15 times m, which is times 4, plus 6 times 4. Simplifying, parentheses, we have nothing going on really in the parentheses. Exponents, nothing going on with exponents. Multiplication, division, so we have 15 times 4, which is going to be 60. And we have 6 times 4, which is going to be 24. Add those together, this will be 84 gigabytes in 4 months.